So this binomial distribution, we will encounter again the ideas about it in the next chapters. So it was a little bit of a flavor of binomial distribution. That's pretty much all we need in chapter 4. Section 5 is always being skipped. We never worry about it. And now we're entering into, I guess, the actual statistics part of the course. So this deals with normal distribution. We already encountered binomial distribution, and now I'm going to take a look at the most popular distribution that is called normal, simply because pretty much everything on our planet happens to be going under this distribution. So any population that you encounter is distributed normally. And that's why this is so important to learn this story. You also can see the picture of normal distribution. It has a shape of a bell. You can see distribution here of men, of women, and mean is always where we have a maximum. Let me go back a little bit. That's where they actually define the normal distribution here. They say that picture here with the probabilities on the y-axis, and the highest probability, the maximum, is attained at the mean, which is mu here. So that's the most of the chance to happen. And of course, there are some chances for the other values to be happening. So the farther you go from mean, the lower the probability is, the less of the chance. Well, it turns out that this bell-shaped curve has a special equation that they say here, and we're never going to work with this, because with this formula they work in mathematical statistics class and they calculate those probabilities using this formula. But in our class we will be using so-called tables to calculate the values of normal distribution. So tables that look like that, and these tables you can easily find by typing Triola tables in the Google search, and it's free tables. If you purchase the hard copy of the textbook, then this be an insert, but you could just type Triola tables and it's always available for free online. I can also put the link to these tables in the chat. So you can click on it and you will see these tables that actually calculated by using those areas under the normal curve, but we don't need to learn how to integrate for that. We just look at the tables and use them. So in this insert to the textbook, they have a few pages, and on the first page there are some formulas that we used already. Some formulas we don't need. For example, the very first formula for a sample mean we used back when we took midterm exam. Also, there is a friend of this formula, so-called sample standard deviation. For the next chapter, there is a complement formula. That's the one that we used a lot, right? So they also have the probabilities and then B, so that means a product. So there are various formulas that we already used. In the chapter that we just finished with, we had those two formulas, mean and standard deviation for binomial distribution. So it looks like that we indeed utilize some of these formulas. I didn't show you those formulas because there are just too many of them, more than you need, so it could be a little bit confusing in here. And now chapter 6 that deals with normal distribution, we will utilize some formulas that appear under this chapter 6 story, which is actually chapter 5 in this edition of the textbook. So anyways, I'm gonna leave these pages for now and move to page that we really need. And this is a z-score story that is actually utilized by so-called standard normal distribution. So it turns out that they designed these tables for a special kind of distribution called standard normal. So let me go to the textbook and show you that special distribution is defined such a way that average or mean is equal to 0 and the standard deviation is equal to number 1. I know it's pretty rare case when you have such a average or mean, which is right there in the center. So they say it here, mean is 0, and also standard deviation equal to 1. But turns out that later we will see how to convert any normal distribution to this particular standard normal. Today's plan is to start to get used to the tables so we can see how tables are being used. And for that matter, I could see how they propose to do this, but first I can notice one important fact about every single distribution. They say that area under this curve, so this entire area below my normal curve, must be equal to 1. And that's the key idea for any distribution. So if the entire area is 1, then it's a distribution. So for a standard normal distribution, we have the mean in the middle at 0.0, and the picture is going to be symmetric, which means that if I produce this line from mean and up, then here will be exactly a half of my area and half of the area, which is 1, is 0.5. So half of area to the left or to the right from mean. So that's why people try to describe this area the following way. They say probability that z, notice that this axis they like to call as a z-axis or use so-called z-score word, and they say that z is greater than 0, so that area that I just highlighted, they define as a probability. And that's the key part of this chapter, is to realize that the area and the probability is exactly the same thing. So areas are probabilities. And this enables us to use these tables that we'll discuss a little later. And we just noticed that since areas half or 0.5, then so is the probability, the chance that our z-score, so on the, instead of x-axis, I put z-axis. So z is used when you have a standard normal distribution with mean is 0 and standard deviation is equal to 1, only under these two conditions. So it's just vocabulary or notation, people say, that we describe those probabilities with symbols instead of writing all that with words. So they say the probability or area from the value of 0 to the right. So they say that z is greater than 0 is whatever we have here. And analogously, if you're going to look at the other side, so from 0 to the left, it looks like since the whole area is a 1, then the area from 0 to the left, or for values of z smaller than 0, which is the same as probability, is also going to be 0.5. So we've got another side of the same picture. They actually, it could be pulled from the tables. So if you look at the tables that give you areas from 0 to the left, it turns out I need to find the page where they have so-called positive z-scores. Notice that if you are dealing with this distribution and 0 will be in the center, then on one side will be positive numbers, right? And on the other side of 0 will be negative numbers. So if numbers are positive, bigger ones, bigger than 0, well, then we have positive z-scores. And the previous page is for those values of z that are negative or on the left side from 0. So it looks like we'll be using two pages depending on what sign is with the z-score. And it turns out that if a z in this case is compared with 0, in other words, if z is 0.000, one can say, why is that? Why don't you put 0.0000? Well, it turns out for the tables, I need to have hundreds. So I need to have 2 decimals. And the way to use it is to get tens on the first row, 0.0 for the first row, and hundreds from the second. And where they meet each other, you will get your probability. So we just saw that probability was 0.5, and that's exactly what is given by the table. So it's Alex, that's not 0.5, it's like 5000. Well, yeah, they give 4 decimals to be consistent with all the other values, but it is really for z equal to 0.00. So we compose 0.0 with 0.00. So we this way find a row and a column. So column always given by hundreds. So I need to have 0 hundreds or 1 hundreds or 2 hundreds or so forth. And in the first column then, and the first row, there will be my answer. Sometimes people ask, do I have to put areas 0.5 or just 0.5? Well, that's the same thing. Notice that in the textbook, sometimes they put 0 in front and sometimes they don't. Like here, they could have put 0.5, but they don't. So it's really up to you. If you like 0 in front, you can put it. It's the same thing, and it's good to realize. So let me try to see how they recommend to use these tables here in the textbook. So they give you a little example here. They talk about some thermometer story, an example on that page, which is numbered 252. So they say that, what about finding the probability that we're on the left side from, so z is smaller, that's what on the left side means, from 1.58. So to find that probability, I'm going to have to use tables. So I'm going to need to go back to this tables here. And I'm going to need to get the 0.08 separated from my number, because we need to know the place of hundreds, right? So place of hundreds, since we have 8 of those hundreds is here. And then 1.5 will be my row that we select. So on the intersection of 1.5 and 0.8, I have this number. So if you imagine yourself the same picture for normal distribution as they give us up here, and the z-square is a little bit to the right from 0 because it's positive, then the area I need, which is everything on the left side from the number, this entire area is 0.9429. So it's about 94%. The probability is about 94%. Let me write 9, the way that everybody will see it better. So 0.9429. So area is the same as probability, and notice that they also stated here, so everyone realizes that we find area from the left. So it's a number, and the area goes to the left side. So this is 0.9429. So let us go to the exercises. First of all, you can check and see that that's exactly what they also have in the textbook, looks like, right? 9429. And they found it from that same exact table. So I'll go to the end of the section as usual and practice to use these tables, because the rest of the story is all about using the table. So I'm going to do problem number 9. Now for a change, I'm going to try negative z-square and see how this is going to be different, or if that be the same, if you have to find the area from minus 0.25, right, all the way to the left. So in exercise number 9, I want to write down the probability that z is smaller than negative 0.25. As usual, I want to make a picture here and get a 0 as usual in the center, so negative number is somewhere to the left from 0. So my area will be again on the left side from number minus 0.25. So let us get the tables and locate that negative number. So first of all, this is positive z-scores. That's not what I need. I want to go up where I see negative z-scores. So I need to see where the negative 0.2 is. It looks like on the very, very bottom, I can see that negative 0.2 for the row. And my column will come from 0.05 because that's a 5 hundredths. So where minus 0.2 meets 0.5, well, looks like this is the location. It's a 0.413. So this area is 0.4013. And this means that my probability is also 0.4013. So this is the answer for the exercise we just saw here for problem number 9. So when it's less, it's always coming from tables. Once again, if I go back to the tables, you can see that they give area from the left. No matter what, it's always area from the left. That's how the table is constructed. And if someone wonders, what about area on the other side, on the right side? Well, we can look at exercise like number 13, for example, that says, what about greater than 233? So if I want to write this down first, to say that we need to find probability that z is now greater, right, than 233. And again, produce a picture of that bell-shaped curve, standard normal distribution, 0 someplace here. Well, 233 is bigger than 0, so it is to the right. And I need to get the area of that so-called tail. People call it as a tail. So I'm going to be dealing with the tables and looking at positive z-score now. So again, I scroll down, go to this positive z-scores. So we need the row and the column, right? So for the column, I have 300s. Okay, so 300. So notice it doesn't matter, greater or smaller. All I can do is find 2.33. So I go for 2.3 with the row and another 3 or 0.03 with a column. So I've got the area, but this area is from 233 to the left. 0.9901 is not what I need, but that's what I'm going to use because once again, I got area from z to the left. What about the other side? What about the complement of this? Remember, the whole thing is 1, so we find the complement. So I have to minus that 9901 from 1. So 1 minus 9901 gives us the answer. It's a 0.099, right? Looks like we've got the answer. And here, 0.099 subtracted from 1, that area. So if you need the other side, fine. You just want to subtract the area from 1. And then be standard for all of those areas on the right side. So tables give you area on the left side. On the other side, the opposite, the complement, will be just subtract from 1. I guess that's our old favorite, right? The complement formula. So let's do some more of these. I hope you start to get used to this a little by little. And no worries, if not, you will get used to them because we'll do this a lot. Throughout this whole chapter, we'll be getting used to these tables. So let me try exercise 21. That says, how about if you try to find the area in between. So probability, which is same as area, that we are in between of negative 2.67 and positive 128. Okay, between negative and positive. So looks like I need to use tables twice. So let me make a picture first. Once I will use these tables for the positive value. So the positive 128 is somewhere on the right side from 0, right? And negative 267 is somewhere on the left side from 0. So what we need is to find the area of region which is lying right in between of these two. Okay, so let's get those numbers pulled out from the tables. So it looks like I'm on the positive page, so I'm going to look at the 8, right? Hundreds. So I'm going to take 128, in other words. So 1.2 is here, 0.8 is right there. So the row and the column will meet, you see, at this number. So what kind of area did I find? Well, as usual, from 128 all the way to the left. So this area I just highlighted, the big area was 0.8997. 89.97 is this entire orange area, which is a little bit more because it has extra little tail, right? So now I need to go for the second number. I need to find 7 of those hundreds, but first I need to go to the negative z-squares. So 0.07, that's for my column, 0.7 right here, and the row is negative 2.6. Okay, negative 2.6 is here. Actually, careful, 2.6 is lower, right? So let me clean this. Negative 2.6 is this row. And on the intersection with a column that has 0.07 above, I get the area, and this area be 0.0038, right? 38. This is area to the left from my negative 20, actually 2.67. And that's what I don't need. That's what I need to throw away or subtract from my whole thing. So when I subtract these two areas, I'm going to actually get the answer. And the answer will have something like 9, and then 5, and then 0.89, and that's it. So 0.8959 is a difference of these two areas. So it turns out I always take difference of those areas if I need to find in between, because one is always bigger that contains the smaller, so I have to cut out that little small area. So I hope you are getting used to this. So I'd like to do one problem and then have you try one. I want to do problem number 12 and then have you do number 10. So exercise number 12. We need to find again probability, which is same as area, that z is less than 275. So I already know how to use tables. I must pick the place of hundreds. So to pick the place of hundreds and find the area to the left from 2.75. So that's going to be the area that tables always provide me with, area from number to the left. So we'll go for the positive page and look for 275. So 05 is what I need up there. 5 hundredths, right? And then 2.7, so that's the row next to 2.7, the column under 0.05 will give us the number on their intersection. And it looks like this is it. That's what I need. So this area is actually 0.997. I guess you don't need that 0 after the decimal point. That's fine. So let's have you try to do problem number 10, right? So let me prepare it for you so it's going to look nice and the way we used to already do this. So for problem number 10 that we have for a little quiz for today, please find the area which is the same as a probability that z is less than negative 2.75. And I'll open a table for you so you can use this table. So I need negative table now. So I put this negative table open for you. So try to locate the area that corresponds to this negative 275 here in the tables. And as usual, just put the answer for me in the Zoom chat. And after that, you can enjoy weekend. Again, weekend is coming. It's Thursday morning, so put the answer in the Zoom chat and have a good weekend.